the transition rate, the hazard, is just 1 over this. You can represent this flow, you know, using this divided by that, which is just, of course, mathematically this times 1 over that, right? It's just, that's a familiar thing. So fixed rates are hazards. We're dealing with the chance of individual transitions. We don't need to multiply by the number of people at risk here. We're dealing with each individual. And these rates can change over time, but importantly, here, the rates for an individual can change over time depending on how long they've been there. But the state chart needs to be made aware of these changes. So there's a couple ways of doing this within AnyLogic. But fundamentally, if your chance per unit time of leaving that state and going to this next state changes based on how long you've been here, for example, in the susceptible state, you have to get it to kind of recalculate at what time you're going to leave. We'll see some examples of that. In the meantime, though, I'd like to go back and I'd like to look at a fixed residence time. Okay, sometimes we have processes that occur according to fixed schedules. It's not a chance per unit time. It's more or less fixed. So in a non-relativistic context, aging occurs at a fixed rate. Similarly, so you might, you know, go between age 0 and 1 and 1 and 2 and 2 and 3, and at some fixed time. It's exactly a year's time, not on average a year's time, but exactly. Similarly, there might be some processes associated with treatment, delivery of an intervention, which are occurring on very well-defined time constants. We can impose that using what are called